students, how are you? In this video lecture, today we will see how to find out hybridization of any molecule, any species within minute. There are some tricks. So applying these tricks, we can find out hybridization of any molecule, any species within minute. So to understand this video, watch this video till the end. अगर आपको पसंद आता है तो लाइक इट, कमेंट इट, शेयर इट एंड सब्सक्राइब इट. तो ये ट्रिक्स कौन सी है? सो सपोज स्पेसीज इज गिवन, दैट इज कैटायनिक स्पेसीज, अनायनिक स्पेसीज, और उसमें कौन सा हाइब्रिडाइजेशन है फाइंड आउट करना है तो हम निकाल सकते हैं. एंड विदाउट राइटिंग स्टेप्स इन्वॉल्व इन हाइब्रिडाइजेशन, दैट इज स्टेप 1 ग्राउंड स्टेट इलेक्ट्रॉनिक कॉन्फिगरेशन, देन एक्साइटेड स्टेट इलेक्ट्रॉनिक कॉन्फिगरेशन ऑफ सेंट्रल एटम, then mixing and recasting, that is hybridized state. So without these steps we can find out hybridization of any species, that is negatively charged, positively charged or a neutral molecule within minute. So what are these tricks? Trick number 1. So by knowing number of bond pairs and lone pairs. Bond pair electrons involved in bond formation. Lone pair and a non-bonding. So, but how to find out lone pair? Number of lone pairs is equal to valence shell electrons in central atom minus number of bond pairs divided by 2. We can judge about bond pairs easily by seeing the structure of that molecule, that compound, that species. Structure से हमें पता चलता है कि उसमें कितने बॉन्ड पेयर्स हैं. लेकिन लोन पेयर के लिए ये फार्मूला, नंबर ऑफ लोन पेयर्स इज इक्वल टू वैलेंशियल इलेक्ट्रॉन्स इन ए सेंट्रल एटम, यहाँ पर सेंट्रल एटम पता होना चाहिए, वो पता चल जाता है, माइनस नंबर ऑफ बॉन्ड पेयर्स डिवाइडेड बाय 2. व्हाट इज सेकंड ट्रिक? n इज इक्वल टू हाफ इनटू v प्लस m प्लस a माइनस c. अब यहां पर n क्या है? नंबर ऑफ एटॉमिक ऑर्बिटल्स और हाइब्रिडाइज्ड ऑर्बिटल्स. हाइब्रिडाइज्ड ऑर्बिटल्स, इसमें v क्या है? नंबर ऑफ वैलेंस शेल इलेक्ट्रॉन्स इन सेंट्रल एटम. यानी सेंट्रल एटम के आउटर शेल में कितने इलेक्ट्रॉन्स हैं? कैपिटल M number of monovalent atoms, number of monovalent atoms, यानी जिसकी वैलेंसी 1 है. ऐसे कितने एटम्स हैं? A, it is negative charge, that is anion. B, that is C, that is positive charge. Yani this is about cation. So by knowing N, V, M, A, C, we can find out hybridization. By knowing number of bond pairs and number of lone pairs, we can find out hybridization. Examples. I will take first methane. अब इसमें सेंट्रल एटम कौन सा है? सेंट्रल एटम कार्बन है. We know that structure of methane, हम इसे निकालते हैं. स्ट्रक्चर है, दिस इज द स्ट्रक्चर ऑफ मीथेन. कार्बन इज टेट्रावैलेंट हियर बिकॉज कार्बन इज सराउंडेड बाय 4 हाइड्रोजन एटम्स. सो वी कैन अप्लाई बोथ ट्रिक्स. फर्स्ट आई विल अप्लाई फर्स्ट वन, दैट इज बाय नोइंग नंबर ऑफ बॉन्ड पेयर्स. हाउ मेनी बॉन्ड पेयर्स आर देयर? हाउ मेनी बॉन्ड पेयर्स? 1, 2, 3, 4. देयर आर 4 बॉन्ड पेयर्स. इसमें लोन पेयर्स कितने? सो नंबर ऑफ लोन पेयर्स इज इक्वल टू, अब यहां पर सेंट्रल एटम कार्बन है एंड कार्बन का इलेक्ट्रॉनिक डिस्ट्रीब्यूशन है 2, 4, एटॉमिक नंबर 6 है. सो वैलेंस शेल इलेक्ट्रॉन्स कितने? 4. फार्मूला क्या है? नंबर ऑफ लोन पेयर्स इक्वल टू वैलेंस शेल इलेक्ट्रॉन्स इन सेंट्रल एटम माइनस नंबर ऑफ बॉन्ड पेयर्स. सो हियर 4 minus how many bond pairs are there? 4 divided by 2, यानी 0. 4 bond pairs and 0 lone pairs. तो a first bond pair, a second bond pair, a third, a fourth. So here mixing and recasting of 4 atomic orbitals. Here it is the first hybridized orbital, this is second hybridized, third hybridized and fourth. तो इसमें एक S होगा और remaining 3 P यानी sp3. So hybridization of carbon and methane is sp3. So what about second formula? N is equal to half into V plus M plus A minus C. Now here N is equal to half. Number of valence shell electrons in central atom. Answer is 4. Plus how many monovalent atoms are present in methane? This carbon is surrounded by 4 hydrogen atoms and we know that hydrogen is monovalent. उसके valency 1 है. Na4 plus is there a negative charge? यहाँ पर negative charge नहीं है. Na0 minus. Is there any positive charge? Positive charge भी नहीं है. Na0. So here it is half into 8. We got 4. And there are 4 atomic orbitals and we know that atomic orbitals equal to hybridized orbitals. यानी यहाँ पर एक S होगा and 3p. यानी hybridization is sp3 and जब hybridization sp3 होता है तो उसकी geometry क्या होती है? Tetrahedral. So geometry of this molecule is a tetrahedral. It is like this. So this bond angle is what? 109.5 degree. So this is a regular tetrahedral geometry. A regular tetrahedral because bond angle is 109.5 degree. Isn't it? So total number of hybridized orbitals are 4. Isn't it? Total number of hybridized orbitals are 4. So this is the hybridized orbital of carbon. Second hybridized sp3, third sp3, fourth sp3. Now here there is overlapping between sp3 and hydrogen. So here it is hydrogen, third hydrogen, fourth hydrogen. So here it is bond pair, second bond pair, third bond pair and the fourth bond pair. So geometry is tetrahedral. Bond angle 109.5 degree. There is no lone pair. अगर किसी मॉलिक्यूल में लोन पेयर नहीं होता तो ज्योमेट्री रेगुलर होती है. Isn't it? Another example. I will take ammonia. Ammonia. By applying this formula, by knowing that is the number of lone pairs and bond pairs. Abhi nitrogen is surrounded by 3 hydrogen atoms in it. Definitely number of bond pairs are 3. Abhi lone pairs. यहाँ पर central atom nitrogen है. Distribution of electrons in nitrogen 2 5. So here outer shell electrons are 5. यानी 5 minus. How many bond pairs are there? 3 bond pairs. So divided by 2. And 2 divided by 2 यानी there is 1 lone pair. यानी अमोनिया में एक लोन पेयर है. एंड हाउ मेनी बॉन्ड पेयर्स? 3. रिमेंबर लोन पेयर भी हाइब्रिडाइज्ड ऑर्बिटल में होता है. तो यहां पर मिक्सिंग एंड रिकास्टिंग ऑफ अगेन 4 एटॉमिक ऑर्बिटल्स. मिक्सिंग एंड रिकास्टिंग ऑफ व्हाट? 4 एटॉमिक ऑर्बिटल्स. सो इसमें एक S होगा एंड रिमेनिंग 3 एंड हाइब्रिडाइजेशन इन अमोनिया sp3. लेकिन यहां पर एक लोन पेयर है तो ये नाइट्रोजन है. A first sp3 having lone pair, second sp3 having single electron, third sp3 single electron, fourth sp3 single electron. यहाँ पर overlapping हो रहा है and this nitrogen is surrounded by 3 hydrogen atoms. So here it is the first hydrogen, this is second hydrogen, this is third hydrogen. And geometry is what? Again tetrahedral. Geometry is a tetrahedral. So what about bond angle? यहाँ पर एक लोन पेयर है तो लोन पेयर और ए बॉन्ड पेयर यहाँ पर इंटरेक्शन होगा, इनमें रिपल्शन होता है. We can explain on the basis of valence shell electron pair repulsion theory. We have seen about this. You are well familiar with this. यहाँ पर भी एक इंटरेक्शन है, that is lone pair bond pair and twice lone pair bond pair interaction is there. And यहाँ पर repulsion है. So what happens? So this bond pair will shift in this direction. Similarly, this bond pair will shift in this direction. So here bond angle is what? 107 degree. Methane में bond angle कितना था? That is 109.5 degree. यहाँ पर कितना है? That is 107 degree क्योंकि यहाँ पर एक lone pair है. So by applying second formula, N is equal to half Number of valence shell electrons in nitrogen 5. अमोनिया में मोनोवैलेंट कितने यानी जिसके वैलेंसी 1 है 3 because 3 hydrogen atoms. There is no negative charge or positive charge यानी +0 -0. तो इसका आंसर आएगा दैट इज हाफ इंटू 8 दैट इज 4 एटॉमिक ऑर्बिटल्स यानी sp3. सो बाय अप्लाइंग बोथ ट्रिक्स विल गेट द आंसर. आपको आंसर मिलेगा. जस्ट आपको रिमेंबर क्या करना है दैट इज फार्मूला, ए फर्स्ट फार्मूला, सेकंड फार्मूला एंड बॉन्ड एंगल्स. इफ बॉन्ड एंगल इन केस ऑफ दैट इज टेट्राहेड्रल ज्योमेट्री 109.5 डिग्री तो ज्योमेट्री रेगुलर होती है. यानी वी नो दैट व्हेन देयर इज नो लोन पेयर ऑफ इलेक्ट्रॉन, अगर किसी मॉलिक्यूल में लोन पेयर नहीं होता तो ज्योमेट्री रेगुलर होती है. अगर लोन पेयर होता है तो ज्योमेट्री डिस्टॉर्टेड है. अमोनिया ज्योमेट्री टेट्राहेड्रल है लेकिन रेगुलर नहीं. ज्योमेट्री इज व्हाट? डिस्टॉर्टेड टेट्राहेड्रल. डिस्टॉर्टेड टेट्राहेड्रल ज्योमेट्री. एग्जांपल नंबर 3. थर्ड एग्जांपल, I will take water. यहाँ पर सेंट्रल एटम ऑक्सीजन है. दिस ऑक्सीजन इज सराउंडेड बाय 2 हाइड्रोजन एटम्स एंड हाउ मेनी बॉन्ड पेयर्स आर देयर? नंबर ऑफ बॉन्ड पेयर्स आर 2. लोन पेयर. यहाँ पर सेंट्रल एटम ऑक्सीजन है, इलेक्ट्रॉनिक डिस्ट्रीब्यूशन 2 6 यानी नंबर ऑफ वैलेंस शेल इलेक्ट्रॉन्स 6. सो 6 माइनस हाउ मेनी बॉन्ड पेयर्स आर देयर? 2 डिवाइडेड बाय 2 यानी इसका आंसर आएगा 2. एंड वाटर में 2 लोन पेयर्स है एंड वी नो दैट लोन पेयर्स ऑलवेज प्रेजेंट इन हाइब्रिडाइज्ड ऑर्बिटल्स. 2 bond pairs and 2 lone pairs. So here also mixing and recasting of what? How many atomic orbitals? 4 atomic orbitals. So एक S बाकी के A Px Py Pz and here also hybridization is sp3. Now apply second formula. N is equal to half. N is equal to half. Number of valence shell electrons in central atom that is 6 plus. वाटर में मोनोवैलेंट एटम्स कितने? 2. हाइड्रोजन मोनोवैलेंट 2. दिस इज अ न्यूट्रल मॉलिक्यूल. देयर इज नो नेगेटिव चार्ज यानी +0 एंड -0 यानी इसका भी आंसर 4 आएगा. 4 यानी 1s एंड 3p. sp3 हाइब्रिडाइजेशन यानी there are 4 hybridized orbitals. So this is the first hybridized with lone pair of electron. This is second hybridized with lone pair of electron. This is first bond pair. Yeah, this is the first bond pair. This is second bond pair. So this is a hybridized oxygen. In hybridized oxygen, in these 2 hybridized orbital, lone pair of electrons are there and in remaining that is single electron about oxygen. I'm talking about oxygen. Now when there is overlapping with hydrogen, a first hydrogen, second hydrogen, तो हाइड्रोजन का एक इलेक्ट्रॉन. So this is the first bond pair, this is second bond pair. Here also geometry is what? Tetrahedral. Geometry is a tetrahedral. Now we'll see about whether it is a regular tetrahedral or what? A distorted tetrahedral. So here it is a lone pair of electron, lone pair यानी यहाँ पर क्या होगा? lone pair repulsion होगा. एक lone pair repulsion. यहाँ पर lone pair bond pair repulsion होगा. यहाँ पर भी lone pair bond pair repulsion होगा. So shifting of these 2 bond pairs in this direction and definitely there is a decrease in bond angle. What is a regular tetrahedral bond angle? A regular tetrahedral bond angle is what? 109.5 डिग्री. हम मीथेन में देखा. अमोनिया में कितना था? अमोनिया में that is 107 डिग्री. In case of water, remember this bond angle is 104.5 डिग्री. यानी वाटर में कितना है? 104.5 डिग्री है. So what is the total deviation? Total deviation is about 5 डिग्री. यहाँ पर 2.5 डिफरेंस है, यहाँ पर भी 2.5 डिफरेंस है. अमोनिया में एक लोन पेयर है, सो बॉन्ड एंगल डिक्रीज बाय 2.5 डिग्री. वाटर में 2 लोन पेयर्स है, सो बॉन्ड एंगल डिक्रीज बाय व्हाट? 5 डिग्री यानी 104.5 डिग्री. सो ज्योमेट्री इज नॉट रेगुलर, ज्योमेट्री इज अ डिस्टॉर्टेड. Geometry is a distorted tetrahedral. Another example, that is BF3, boron trifluoride. How many bond pairs are there? Number of bond pairs. 3 fluorine atoms and 3. So what about lone pair? No. So here boron is the central atom. Boron का electron distribution क्या है 2 3 atomic number 5. So number of valence shell electrons are 3. So 3 minus 3 divided by 2 यानी there is no lone pair. And only 3 bond pairs are there. So this is the first bond pair, this is second bond pair, this is third bond pair. And a mixing and recasting of how many atomic orbitals? यहाँ पर 3 and 3 atomic orbitals का मतलब होता है 1s and remaining are what? P. And hybridization is sp2. You can apply this formula. N is equal to half. N is equal to half. Number of valence shell electrons in central atom 3 plus number of monovalent. Fluorine की valency 1 है. 3 fluorine atoms, so 3. This is a neutral molecule. There is no negative or positive charge. And answer 3. And there are 3 atomic orbitals. 3 atomic orbitals are involved in this hybridization. So type of hybridization is what? sp2. And 1s and 2p. And when hybridization is sp2, geometry is what? Planar or trigonal. And this boron is surrounded by 3 fluorine atoms. It is like this. So this is a planar or trigonal. Planar trigonal. Another example, BeCl2. Beryllium is surrounded by 2 chlorine atoms. Central atom यहाँ पर beryllium है, and we know that distribution of electrons in beryllium 2 to atomic number 4. And how many bond pairs are there? Bond pairs are 2. How many lone pairs? Lone pair number of lone pairs equal to number of valence shell electrons 2 minus 2 bond pairs divided by 2, and it is 0. Yani only 2 bond pairs are there. Yani only 2 atomic orbitals are involved in this hybridization. So one is S and another is P. So this is sp. This is what? sp. And only 2 hybridized orbitals are there. See here, this is the first sp. This is second sp having 1 electron. Now here chlorine है. Chlorine का p atomic orbital with unpaired electron. See here, this is the p atomic orbital of chlorine with unpaired electron. This is second p atomic orbital of chlorine with unpaired electron. So here it is a beryllium, ये chlorine है, ये chlorine है. So इसकी geometry linear है, shape diagonal, and geometry that is linear geometry. This hybridization is also known as the diagonal hybridization. You can apply this formula. N is equal to what? Half. Number of valence shell electrons in central atom 2 plus number of monovalent 2 plus 0 minus 0. यहाँ पर भी चार्ज नहीं है, न्यूट्रल मॉलिक्यूल है, यानी हाफ इंटू 4, यानी इसका आंसर 2 यानी sp. And when it is a linear, so this bond angle is what? This bond angle is 180 degree, isn't it? So here it is a BeCl2. So this bond angle is what? 180 degree. Another example, I will take phosphorus pentachloride. Phosphorus pentachloride. यहाँ पर central atom phosphorus है. Distribution of electrons 285. And a number of valence shell electrons are 5. So how many bond pairs are there? 5 chlorine atoms, and a number of bond pairs are what? 5. 5 bond pairs are there. How many lone pairs? Number of lone pairs equal to what? Number of valence shell electrons in central atom, that is 5, minus, because distribution of electrons about phosphorus 285, atomic number 15 and 5. So 5 minus, how many bond pairs are there? 5 bond pairs divided by 2, yani 0. Yani 5 bond pairs and 0 lone pairs. So again, how many atomic orbitals are the part of hybridization? 5. So here 5 atomic orbitals, yani 5 hybridized orbitals are there. So 5 atomic orbitals, yani 1s, a px, py, pz और a d. लेकिन कौन सा d एटॉमिक ऑर्बिटल? इसमें होगा, because how many d atomic orbitals are there? 5 dxy, dyz, dxz, dx square minus y square and dz square. So यहाँ पर hybridization is sp3d, sp3d. You can apply second formula, n is equal to half. So here n is equal to half. Number of valence shell electrons in central atom 5. How many monovalent atoms are there? 5. There is no negative charge or positive charge, and a plus 0 minus 0, and a half into 10. So answer is what? 5. And sp3d. And remember, when hybridization is sp3d, geometry is trigonal bipyramidal. यहाँ पर phosphorus A equatorial bond and A axial bonds, isn't it? So this geometry is what? Trigonal bipyramidal. Then my question, which d atomic orbital is the part of this hybridization? So here axial bonds are there. Suppose this is z axis, a z axis. So which d atomic orbital lies along z axis? So this is dz square. This is what? dz square. So phosphorus pentachloride, sp3d. Another example. This compound is said to be interhalogen compound, chlorine and fluorine. How many bond pairs are there? Central atom is chlorine. This chlorine is surrounded by 3 fluorine atoms and a number of bond pairs are 3. How many lone pairs? So number of lone pairs equal to what? How to find out number of lone pairs? Number of valence shell electrons in central atom chlorine का electron distribution है 2, 8, 7 and a 7 minus how many bond pairs? 3. 3 bond pairs are there divided by 2 and a 4 divided by 2. 4 divided by 2 and answer is a 2 lone pairs. And we know that 2 lone pairs always present in hybridized orbital. ये 2 lone pair and how many bond pairs? 3. And यहाँ पर mixing and recasting of atomic orbitals कितने? 4. And we know that number of atomic orbitals equal to number of hybridized orbitals. So 4 atomic orbitals and 5 atomic orbitals, not 4. 1, 2, 3, 4, 5. यानी how many hybridized orbitals? 1, 2, 3, 4, 5. तो इसमें एक s होगा, एक 3p होगी और ये लास्ट वाला क्या होगा? ad. यानी hybridization is sp3d. sp3d. Apply this formula. n is equal to half. Number of valence shell electrons in central atom 7 plus how many monovalent atoms? Capital M and a number of monovalent atoms. यहाँ पर 3. This is neutral molecule and is 0 minus 0. There is no negative charge or positive charge. So here n is equal to 5 and 5 atomic orbitals are there, 1s, 3p and 1d and a hybridization sp3d. And we know that when hybridization is sp3d, geometry is what? Trigonal bipyramidal. यहाँ पर 2 lone pair of electrons है तो distortion होगा. It will not be regular data, that is trigonal bipyramidal. So here it is, geometry is like this. And on the basis of valence shell electron pair repulsion theory, different possible geometries are there, but I will explain about only stable. तो यहाँ पर क्लोरीन होगा, फ्लोरीन, a second fluorine, third, and position of lone pair of electrons will be here. ये ज्यादा स्टेबल है, isn't it? A stable geometry है. Now here bond angle is not 90 degree, it is 87.5 degree. ये दोनों बॉन्ड क्लोरीन, ये axial bonds, not exactly axial. Shifting is like this. And what is the shape of ClF3? It is the shape of this molecule is a bent T-shaped. This concept is very important. And here bond angle is not 90 degree and this is not 180 degree, less than 180 degree. क्योंकि यहाँ पर क्या होता है, ये जो लोन पेयर है, ये बॉन्ड पेयर है, इसमें रिपल्शन होता है. लोन पेयर, बॉन्ड पेयर, सिमिलरली यहाँ पर भी रिपल्शन है लोन पेयर bond pair. So that is why shifting of these two bond pairs in this direction. So here bond angle yani FCl, this bond angle is 87.5 degree, not exactly 90 degree. So we can explain on the basis of this, that on the basis of valence and electron pair repulsion theory. Another example. I will take xenon difluoride. Xenon inert gas element, but only xenon can form compounds with fluorine and oxygen due to low IP, isn't it? So here xenon difluoride. Now, first formula, that is by knowing that is number of bond pairs. How many bond pairs are there? कितने bond pairs हैं? 2 fluorine atoms and a number of bond pairs are 2. How many lone pairs are there? xenon के outer shell में कितने electrons होते हैं? उसका octet पूरा होता है यानी 8 electrons. So 8 minus, how many bond pairs are there? 2 bond pairs divided by 2, and 6 divided by 2 and 3 lone pairs. So 2 bond pairs and how many lone pairs? 3 lone pairs. And how many atomic orbitals are required to accommodate all these? See here, total number of atomic orbitals 1, 2, 3, 4, 5. And 5 atomic orbitals, and we know that number of atomic orbitals equal to number of hybridized. तो इसमें एक S होगा, A3P और A rest वाला D, and hybridization is sp3d. So second formula, that is n is equal to half number of valence electrons in central atom 8 plus how many monovalent fluorine की valency 2 है. There is no negative or positive charge. यानी आंसर आएगा 5 यानी S1 S3P and D, यानी hybridization is sp3. So geometry trigonal bipyramidal, but here 3 lone pair of electrons are there. Which one is more stable geometry? Xenon. Here bond pairs will be axial and lone pairs at equatorial. This is the stable geometry. And a trigonal bipyramidal. इसका शेप क्या है? शेप ऑफ दिस, इट इज linear, isn't it? So hybridization sp3d. Another example. How many bond pairs? Number of bond pairs are 4. How many lone pairs? Valence shell electrons 8. 8 minus 4 divided by 2, and answer is 2. And यहाँ पर 2 lone pairs and 4 bond pairs. It is like this. So how many atomic orbitals are required? 1, 2, 3, 4, 5, 6, and a mixing and recasting of 6 atomic orbitals. It is like this. S, P और A क्या होगा? D. And hybridization is sp3d2. Apply the same formula. N is equal to half. Number of valence electrons 8, monovalent 4, neutral molecule plus 0 minus 0, यानी half into 12, यानी 6. How many atomic orbitals? 6. 1, 2, 3, 4, 5, 6. Hybridization is sp3d2. And when hybridization is sp3d2, उसकी geometry क्या होगी? Square planar bipyramidal. So geometry is square planar bipyramidal. Here bonding will be equatorial. This is stable geometry on the basis of valential electron pair repulsion theory, a lone pair or a second lone pair. So geometry square planar bipyramidal. Another example, xenon hexafluoride. Number of bond pairs 6 fluorine atoms and 6. Number of lone pairs 8 minus number of valential electrons in xenon 8 minus number of bond pairs are 6 divided by 2, यानी आंसर is 2 divided by 2, यानी there is 1 lone pair. एक lone pair है. And how many bond pairs? 6 bond pairs. And how many atomic orbitals are required? See here. 1, 2, 3, 4, 5, 6, 7. ये S होगा A3P और A3D. and hybridization is what? sp3 d3. Apply this formula. N is equal to half 8 plus 6 plus 0 minus 0 and 7 yani sp3 d3. And when hybridization is sp3 d3, then geometry is pentagonal bipyramidal, and here is xenon. So geometry is what? 1, 2, 3, 4, 5. A fluorine or a lone pair. So geometry is what? Pentagonal bipyramidal. Pentagonal bipyramidal. Another example, xenon trioxide. ऑक्सीजन की वैलेंसी 2 होती है, यानी इन बिटवीन xenon एंड ऑक्सीजन यहां पर डबल बॉन्ड है. सो हाउ मेनी बॉन्ड पेयर्स आर देयर? नंबर ऑफ बॉन्ड पेयर्स. अभी इसका स्ट्रक्चर क्या होगा? ये xenon है, सो यहां पर एक डबल बॉन्ड, यहां पर एक दूसरा डबल बॉन्ड, यहां पर तीसरा डबल बॉन्ड है ना. विल फाइंड आउट अबाउट लोन पेयर्स. सो फर्स्ट अबाउट बॉन्ड पेयर्स. अभी डबल बॉन्ड का मतलब एक सिग्मा एक पाई, यानी सिग्मा एक बॉन्ड पेयर है, पाई एक बॉन्ड पेयर है. सिमिलरली सिग्मा पाई, यानी हाउ मेनी बॉन्ड पेयर्स आर देयर? यहां पर 2, 4 और 6, यानी 6 बॉन्ड पेयर्स आर देयर. हाउ मेनी लोन पेयर्स? नंबर ऑफ लोन पेयर्स इक्वल टू 8 माइनस हाउ मेनी बॉन्ड पेयर्स आर देयर? 6 डिवाइडेड बाय 2, यानी एक लोन पेयर है. तो लोन पेयर यहां पर होगी, a lone pair. So a lone pair, and how many bond pairs? There are 6 bond pairs, but इसमें 3 sigma or 3 pi. Remember, only sigma bond is the part of hybridization. Only sigma bond. Pi bond is always unhybridized, and unhybridized atomic orbital gives pi bond, and hybridized atomic orbital gives what? Sigma bond. And we have to consider here total 3 sigma and 3 pi. So don't consider about these. We have to consider about only sigma. Yani how many bond pairs? A3. To find out hybridization, इसमें एक S, PX, PY and PZ. तो हाइब्रिडाइजेशन क्या होगा? sp3. Apply second formula. N is equal to half. Number of valence shell electrons 8. So how many monovalent atoms are present in this molecule? Oxygen is divalent. Monovalent 0. There is no charge. Yani answer is what? 4. 4 and sp3. So what is geometry? It is tetrahedral. Geometry is what? Tetrahedral. Again, it will not be regular because there is one lone pair of electrons, so geometry is tetrahedral. I will take one anionic species, that is SO4 2-. So what type of hybridization is present in sulfur of this SO4 2-? Apply this formula. N is equal to, यहाँ पर central atom sulfur है, sulfur Na2 8 6 6 and a half into 6 plus how many monovalent atoms? No. Oxygen is divalent, there is no monovalent, 0 plus A and a number of negative charges. A 2 minus A, so plus 2 minus, there is no cationic, there is no positive charge, and a 0, यानी half into 8, answer is 4, यानी इसका hybridization है sp3. So by applying these tricks, we can find out hybridization of any molecule, any species, cationic species, anionic species. If any doubt, you can put your doubt in comment box. Definitely, I will get back to you. Thank you.